If black holes swallow everything, how did we ever photograph one? The answer begins with a strange fact: a black hole itself does not shine, but the matter around it can glow after gravity heats it to extreme temperatures. A black hole is not a hole punched through the universe. It is matter compressed into an extreme state. Around it lies an invisible boundary called the event horizon. Once something crosses that boundary, escaping would require a speed greater than light. Since nothing outruns light, not even light can travel back out. In 2019, the Event Horizon Telescope produced humanity's first image of a black hole, the object at the center of M87, about 55 million light-years away. The orange ring is not the black hole itself. It is radiation from superheated gas around it. The dark center is the black hole's shadow, a missing region of light reshaped and enlarged by intense gravity. We are not seeing the black hole directly, we are seeing how it changes the light around it. Light near a black hole does not simply move in straight lines. Mass curves spacetime. Light from the far side of the accretion disk can bend around the black hole and reach us from above and below, making a flat disk look wrapped around the darkness. That is gravitational lensing. The event horizon is not a hard wall. It is a boundary of cause and effect. Messages from outside can still travel outward, anything that happens inside can no longer send a message back to the outside. The light we detect usually comes from the disk, jets, and hot gas that have not yet crossed the horizon. Black holes also come in different sizes. When a massive star exhausts its fuel, it can collapse into a stellar mass black hole. At the centers of many galaxies, much larger black holes hold the mass of hundreds of thousands to billions of suns. If the sun were replaced by a black hole with exactly the same mass, Earth would not immediately fall into it. At the same distance, the mass still determines the main orbit. Earth would continue along nearly the same path, but without sunlight, it would gradually grow cold. A black hole is not a cosmic vacuum cleaner. The danger begins when you get close enough for space-time curvature and tidal forces to become extreme. Near the horizon, a distant observer sees the motion slow dramatically, while for the falling traveler, the path inward continues. So the most useful word for a black hole is not devouring, but boundary. We cannot see its interior, yet we can trace its effects through bent light, hot gas, fast-moving stars, and even gravitational waves. Next, we ask, what happens if you fall into a black hole?